All right, class. Now we'll look at another topic in this sections is the scalar is matrix multiplications. All right, so we first examine if there is a matrix, say B multiplied by a vector x. As a result, it's just what? It's a vector. Okay, then if this vector then multiplied by another matrix A, then A times Bx. Remember, Bx now is a vector, right? Then as a result, this is still a vector, different kind of vector. So what does that mean? So there's a vector acted on. We use the word acted on by B. As a result, there's another vector called Bx right here. Then multiplied by another matrix, so you ended up with A applied to a vector. So the result is a what? Is a vector. Okay, so A, B, X is produced from X by a composition of mapping. You know, map from X to BX, and then from BX map to ABX. Our goal is to represent this composition's composite mapping as a multiplication by a single matrix, meaning you have B times X first, become a vector, and apply A to this particular vector. We want to say, hey, you can go ahead and multiply A and B together as a new matrix, apply to this guy X, you will get the same place, A times BX, A of BX. All right, so we're gonna spend a lot of time talking about a theory. We're gonna go straight to the multiplication again. Here we go. Compute A times B, so where A equals to this, then B equals to that. So how do we multiply A times B? Well, if A times B, meaning if B is B1, B2, B3, actually B1 is 4, 1, B2 is 3, negative 2, B3 is what? 9, 3. And compute the following, AB1, all right? So vector A times B equal to A times B1, the first column, B2, and what? And B3. And then we distribute to all of them, okay? AB1, AB2, and AB3. We can see in here, AB1, AB2, and AB3, right? As a result, they're all column vector, okay? And they're put together in the new matrix. All right, so that's the 2x3 matrix. Is there a better way to do that? Well, what we did here is actually this, okay? Let's say A times B. We got to check, right? You have 3 column, I have 3 row. We can do this, all right? So the compute AB is, if it's a defined meaning, so now we only look at how to attain the 1, 1 position right here first, okay? So this position is being carried by 2 times 2, you see the blue, 3 times 0, you see the red, and see the green. 4 times what? 6 times 4, you get this number. So add together, you get 28, put it right here. Okay? You see how it goes? Second one, again, what about this position? How do we get 45? Negative 45. It's a 2 times 3, as you can see, the blue part, and the red part, 3 times 1, and see the green is 6 times 7. So you get this, I'm sorry, 6 times negative 7. So as a result, it's negative 45. Okay, so it's right here, negative 45, right there. All right, we'll continue, right? What's the next number? That should be a 2 right here. Let's see if we can get there or not. So look at the bolder part. The bolder part is negative 1 times 2 plus 0 times 0 plus 1 times 4. The answer is what? Times 4 is what? It's 2. Exactly, that's what it is. Finally, so this is for this part. Finally, row 1, second column, you get what? So row 2, so there's two position. See that the 2, hey, where to go is what? It's a 2, 1 position. So this is what? 2, 1 position. That makes sense. All right, that's the way we defined before. All right, so let's check another one. All right, let's see. Negative 1, 0, 1 times negative 3, 1, 7. So you can see negative 1 times negative 3 plus 0 times 1 plus 1 times what? Negative 7. As a result, it's a 3, 0. Minus 7, as a result, it's negative 4. There you go. So that's the matrix multiplications.